Hello everyone, welcome to the YouTube channel of Developers and Coders Club NIT Agartala. So here we will be discussing the problem GCD and LCM of starters 104. So in this problem Alice and Bob are playing a game. So they have two integers, positive integers x and y, and in one operation Alice will replace one of the numbers with GCD of current numbers. So she will select either x or y and replace it with GCD of x and y, and then Bob will be replacing exactly one of the numbers with LCM of current numbers. So just suppose you have replaced x. Now you will take the replaced x and y and take the LCM and replace the numbers. So by using this process you have to find the minimum sum of numbers they can achieve after k operations. So let's look at the input format first. So in first line you will be given number of test cases. Then in every test case you will be given three numbers x, y and the k. K is number of operation and x and y are the numbers at which we operate. So output will be the minimum sum of numbers that you can achieve after k operations. So let's look at the test cases and see how it is working actually. So here we take this 3 is the total number of test case, and first test case is 4 2 1. So how are we getting the output 4? We can look here for reference. So we are taking 4 2 and 1. So we will be doing operation one time. So firstly we will take the GCD of 4 and 2, and you will get this GCD. GCD of 4 2 is 2. GCD means just HCF, greatest common divisor actually. So 2 will be the result of this, and then you will be replacing the biggest of these two digits by this GCD. And here we can see in 4 2 the bigger number is 4, so we will replace it by GCD, and the numbers will become 2 2. Now we will take the LCM. What is the LCM of 2 2? It is 2. So now we have to replace this one number by this. So you can replace the bigger of these two, but here both are equal, so we will be just replacing anyone and it won't matter. So 2 plus 2 is equal to 4. That will be our final answer because you have to operate just one time. So we took the GCD, then LCM, and then add up the number, and that's the result. Now look at the second one. So for second one, this is 1 5, and you can operate two times. Okay, so here we take this 1 5. So what is GCD of these two? 1, and then we will replace the bigger of these two numbers by this GCD. So bigger of these two is 5, so we replace it by 1 and we will get 1 1. Now we do the LCM of this, and what will be the LCM? 1 1. Now here we can see our one operation is done. Here we can see one operation. Now we have to do it again, but do we need to actually? You can see 1 1, and you can operate any number of time. You will just get what will be the GCD of 1 1. It will be 1, and then you replace it by it here, and it won't actually matter. 1 1 replace 1, number won't change. Then LCM of these two, again 1. So it doesn't matter actually when your GCD becomes equal to LCM. So now if now here you can see the result will be 1 plus 1 is equal to 2, because this will be your final answer at every case, 1 1. Now we can see the third case, 4 4. Here you can see you have to do the operation 10 times, but do we need to actually? You can say 4 4. So what will be the GCD of this? 4. Now you replace 4 4 by 4 and you get just 4 4. Just you can see here, I will show you. See here your numbers are 4 and 4, Now you take the GCD of these two. What will be the GCD of these two? GCD is 4. Now you replace any of these number by 4, it won't actually matter, right? So it is here 4 4. Now LCM of these two, you can see LCM is also 4. So you replace this here, it won't actually matter, you can do it any number of time, this won't change. So even after 10 times you will just get 4 4. So 4 4, and then you have to add up the two numbers. So 4 plus 4 is equal to 8. This will be your final result here. So you can see, if you get the numbers equal, then the operations start repeating. Actually, then your number of operation doesn't matter, your result will be same. You can see here, actually you can see that when it was 1 1, then it started repeating, because your LCM was always gonna be 1 and your GCD also 1. So the final answer started repeating. So you have to stop at that point when your x and y gets equal, because once x and y are equal, then your GCD will be always x, and that will be your LCM too. Wait, I show you that too. So here you can see, if both numbers become equal, so you can say both are x, both are y and y. Okay, so what will be their HCF? HCF will be always y, and then you replace any of the number by y, it won't matter actually. So it will be y y, and their LCM also same y. So in the end the result will be just y plus y, that will be equal to 2y. So you can see that if somehow x and y gets equal, then you don't have to do any more operations, and if it is not equal, then you have to just repeat the operation, take the GCD, replace it by biggest number, replace the biggest number by your GCD, then take the LCM and replace the bigger number by LCM of the two, and that's how you do this. So now here we have to write a code for it too, right? So here is the code, you can see. Wait, I show you this too. So here you can see that you will take the number of test cases here, then you will take x, y and k. X, y are the number, and k is just the number of times you have to operate. So we can put that in a loop to repeat the operation, and then first operation is taking the GCD. So we are taking GCD at the variable p. So and then we will be replacing the bigger of the two numbers by this p, and then we will take the LCM of new x and y, and then replace the bigger of the two numbers by this q, and then you have to repeat this process k times, but you can break the process when x is equal to y, because then the process starts repeating as I showed earlier. So you can see, so in the end you have to just output the sum of the two numbers. So here is the output. Here we have used this GCD function and LCM function. For solving this question, you can use other ways by making your own function if it is not working there, but you have to also include this numeric to be able to use these two functions, or you can just use bits std c++, it depends on you totally. So you can see this is our required code, and you will get the required result too. Thank you for watching.